We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
NASA's announcement reverberated across the world of science and beyond, carrying the weight of a message that commands attention. 7 comets are on an inward path through our solar system, diving closer to the inner planets and the Sun. Among them, one name already carries notoriety: 3I/Atlas. Once hailed as a rare interstellar visitor, it now has company in a dramatic unfolding that places humanity's eyes once more on the vast reaches of space and the mysteries that drift within it. The alert itself is not the quiet technical note of a research update. It has the tone of urgency, the kind of declaration that stirs both awe and unease, for a fleet of icy wanderers is moving on trajectories that carry them into the heart of the solar system. Before we start, smash the like and subscribe buttons for more updates. The very fact that 7 comets are being tracked simultaneously with this level of precision signals how far astronomical observation has advanced. A century ago, the sudden arrival of even one new comet might have come as a surprise to all but the most dedicated skywatchers. Now, with an array of deep space telescopes and space-based observatories, astronomers not only detect these icy bodies but can forecast their approaches, their brightness, their fragmentation potential, and their orbits long before they become visible to the naked eye. Still, the number alone, 7, suggests an unusual clustering, an influx that feels almost like a wave sweeping into our neighborhood of the galaxy. 3I/Atlas, known to scientists and the public alike as one of the elusive interstellar interlopers, serves as a kind of focal point in this unfolding narrative. Its trajectory and its origins beyond the solar system have already marked it as an object of immense interest. That it is now part of a broader convoy of comets diving inward elevates its significance, making it both a messenger from the distant stars and a harbinger of a celestial spectacle. To speak of it as having company is not a metaphor but a scientific reality, as other cometary bodies of varying sizes and compositions are on paths that echo, overlap, or parallel its journey. The implications stretch beyond simple stargazing. Each comet carries with it a record of primordial material preserved since the earliest days of the universe. Dust, ice, and volatile compounds locked within their cores reveal the chemistry of ancient times. Scientists see them not only as potential hazards, but as archives of cosmic history. To have 7 comets arriving nearly in tandem offers a once-in-a-generation opportunity to compare their makeups, their behaviors near the Sun, and their potential fragmentation. It is as though the cosmos has suddenly opened multiple volumes of its oldest library at once, inviting humanity to read. The mechanics of their journeys draw fascination in their own right. Comets spend most of their lives in distant regions, whether in the Oort cloud, which extends thousands of times farther from the Sun than Earth does, or in the Kuiper belt beyond Neptune. Perturbations, gravitational nudges from passing stars, giant planets, or even galactic tides can set them on long, looping orbits that eventually bring them into the warmth of the inner solar system. When that happens, the frozen volatiles within them begin to sublimate, releasing jets of gas and dust that create the shimmering comas and tails for which comets are famous. Multiply that process by 7, and the sky itself becomes a shifting canvas of luminous visitors. Astronomers will not simply watch with curiosity, they will marshal instruments across the world and above it. Radio telescopes, optical observatories, and spacecraft will all play their part in tracking the comet's evolution. Already, teams are running simulations of orbital paths, plotting close approaches to Earth, Mars, or the Sun, and assessing whether any fragments might pose risks. The red alert does not imply certain catastrophe, but instead underlines the seriousness of monitoring so many simultaneous arrivals. The lessons of history, Tunguska, Chelyabinsk, remain vivid reminders of how even small celestial fragments can deliver immense energy to a planet's surface. Yet beyond the pragmatic calculations lies the profound sense of spectacle. Comets, when seen with the naked eye, evoke emotions that blend fear, wonder, and reverence. Ancient civilizations often regarded them as omens, and even in our modern age of data and analytics, their beauty has the power to inspire awe. The thought of 7 comets blazing across the heavens in succession or even simultaneously stirs imaginations worldwide. For amateur astronomers, for children peering through backyard telescopes, for communities gathering under dark skies, this moment promises to etch itself into memory. 3I/Atlas, as an interstellar body adds an extra layer of drama. Unlike comets bound to the sun, its passage is a fleeting visit. Once gone, it may never return, hurtling instead back into the void between stars. Its interaction with the sun and the gravitational pull of planets may alter its course slightly, but its destiny lies beyond our reach. That makes its presence during this convergence a kind of cosmic coincidence, a reminder of how vast and dynamic the universe truly is. Alongside the other comets, likely natives of the solar system, it becomes a symbol of two worlds meeting, the local and the foreign, the familiar and the strange. The challenge for scientists will be balancing the pursuit of knowledge with the responsibility of vigilance. Each comet's trajectory must be plotted not just for scientific interest, but for planetary defense. The red alert encapsulates this duality, celebration of discovery mingled with sober awareness of risk. Space agencies around the globe, not just NASA, will exchange data, refine predictions, and prepare strategies. Should even one fragment be identified on a collision course with Earth, international coordination would become essential. The technology to deflect or mitigate such a threat remains experimental, but the very act of preparation underscores humanity's evolving role as stewards of our planet in a cosmic context. At the same time, the cultural dimension cannot be overlooked. News of 7 incoming comets resonates far beyond the scientific community. It becomes the subject of art, literature, debate, and even mythology. People will imagine what it means for the night sky to host such a display. Some may see it as a reminder of humanity's smallness, others as an invitation to look upward and outward. In classrooms, children will learn not only about physics and chemistry, but about imagination, the sense of connection to something greater than Earth alone. In cities, conversations will spark about visibility, about the right moment to look up. In rural regions, dark skies will once again become stages for performances that no artist can replicate. The clustering of comets also prompts questions about cycles and patterns. Is this simply coincidence, or does it reveal some deeper gravitational rhythm of the solar system? Do galactic processes occasionally shake loose multiple objects at once, sending them sunward in groups? Astronomers are keenly aware that while individual orbits can be charted with precision, the larger dynamics remain partly mysterious. Every cluster observed helps refine models, improve predictions, and sharpen humanity's ability to anticipate future waves. The present moment is both singular and part of a continuum, a reminder that the cosmos is in constant motion. The tails of these comets, once they flare near the sun, will differ depending on composition. Some may produce wide fans of dust visible for weeks, while others may shine briefly before breaking apart. Their brightness may vary wildly, and surprises are always possible. Cometary science is notorious for defying expectations. A dim body can suddenly outburst, growing a tail that dominates the sky. A promising comet may crumble before reaching peak visibility. With 7 in play, the range of outcomes multiplies, ensuring that the coming months will be filled with anticipation and shifting headlines. Each observation, each adjustment to predictions adds to the unfolding drama. International collaboration is likely to intensify. Agencies in Europe, Asia, and South America will track the comets from different vantage points, ensuring round-the-clock coverage. Proposals may even emerge to redirect spacecraft or plan quick missions, though the timeframes are tight. Remote sensing, high-resolution imaging, and spectroscopic analysis will be marshaled to glean as much data as possible. The comets are not simply objects to watch passively. They are active laboratories, testing grounds for understanding chemistry, physics, and celestial mechanics in real time. Every jet of gas, every fragmentary split, every spectral signature is a clue. The involvement of the public will also play a role. Citizen scientists armed with small telescopes and digital cameras can contribute observations that professional astronomers cannot always capture, especially in regions where professional observatories are sparse. Networks will spring up online, sharing coordinates, brightness estimates, and photographs. Enthusiasts will compete to capture the best images, the most dramatic sequences. In this way, the story of 7 incoming comets will belong not just to experts, but to a global community of observers, united by curiosity and wonder. Even the language of red alert carries weight. It is rare for space agencies to use such terminology, usually reserved for potential threats. The choice reflects not only the seriousness of monitoring, but also the recognition that the public deserves to know the scale of what is happening. It bridges science and communication, ensuring that the phenomenon is not confined to academic journals, but is shared as part of the collective human experience. The tone sparks urgency, but it also conveys transparency, an invitation for the world to watch and learn together. As the comets approach, they will pass through different phases of visibility. Some may emerge first in the southern skies, later becoming visible in the north. Some may skim close to the sun, visible only in twilight or during carefully timed observations. Others may linger in darker skies, offering prolonged views. The choreography is complex, a ballet choreographed by gravity and time. Each sighting will be an event in itself, woven into the larger narrative of 7 comets in one season. The philosophical implications are not far behind. Comets, as ancient messengers, remind humanity of both its fragility and its potential. They have been linked to the origin of water and organic molecules on Earth, perhaps even to the conditions that made life possible. To see them converge now in such numbers is to be reminded of those origins and to confront anew the question of our place in the universe. Are these icy bodies simply passers-by? Or are they part of a larger dialogue between the cosmos and life? Scientists may not frame it in such poetic terms, but the thought lingers in the minds of many. What unfolds in the skies over the next months will become part of the shared memory of this generation. Whether the comets dazzle or disappoint, whether they break apart or blaze magnificently, the act of waiting, watching, and wondering will matter as much as the outcomes. 3I/Atlas, with its interstellar pedigree, will forever be remembered as the most exotic among them. But the ensemble of 7 will carry a collective identity. The season of comets, the convergence, the red alert, all these phrases will echo in media, in conversations, in the ways people tell stories of the time when the skies filled with icy wanderers. The drama does not need aftermath to have meaning. The very process of witnessing, of calculating, of marveling is its own reward. The comets will dive, the scientists will measure, the public will gaze, and humanity will once again find itself united under the same canopy of stars, reminded that while we may look outward for understanding, the act of looking also turns us inward, toward questions of identity, purpose, and destiny. For now, what matters is the approach. The grand entrance of 7 comets, their tails like banners unfurled across the heavens, heralding a cosmic season that belongs to all who lift their eyes to the sky. The announcement of 7 inbound comets arriving together with 3I/Atlas at the forefront of attention offers a story that is still opening, a cosmic drama expanding in scope and intrigue. It is one thing to recognize a single comet diving toward the sun, but quite another to realize that multiple bodies, each with its own history, its own structure, its own secrets, are converging nearly at once. In this gathering of celestial nomads, every comet becomes a character in a broader narrative, and every trajectory adds to the texture of a moment that scientists and skywatchers alike will study for decades. To appreciate the gravity of such an event, one must first consider the immense distances involved. Comets spend most of their lives in darkness, traveling slowly at the far edges of the solar system, or even between stars. Their journeys stretch across millions of years, through regions so remote that starlight itself seems faint. When a gravitational nudge from a passing object alters their course, they begin a descent inward, accelerating as they fall into the embrace of the sun's gravity. That 7 comets are doing so in overlapping time frames is extraordinary, the statistical odds so slim that it prompts questions about underlying causes. Could it be a passing star's influence? Could distant tides in the galaxy's mass have shaken loose more than one icy traveler at once? The answers are elusive, yet the questions deepen the significance of what is unfolding. Each comet is like a time capsule. Their nuclei, often just a few kilometers across, contain materials preserved from the birth of the solar system over 4.5 billion years ago. Locked within their frozen cores are molecules of water, methane, carbon dioxide, and more exotic compounds, all of which formed in the cold reaches of space before Earth itself even existed. As they approach the sun, these compounds sublimate into gas, creating luminous comas and streaming tails that reveal not only visual splendor but chemical composition. For planetary scientists, this is akin to watching a laboratory experiment play out in the vastness of space. 7 comets arriving together means 7 different data sets, 7 different opportunities to glimpse the ingredients of ancient cosmic chemistry. The scientific instruments designed for these tasks are already being prepared. Spectrographs can split the light of a comet's tail into its component wavelengths, unveiling the signature of each element and molecule present. Radar can probe the size and texture of the nucleus. Space-based observatories like Hubble and James Webb are especially well positioned to analyze the faint and volatile gases that terrestrial telescopes might miss. For researchers focused on astrobiology, these comets may yield clues about how organic molecules formed and whether comets like these seeded early Earth with the precursors of life. Having so many to study at once is like holding a banquet of evidence instead of a single sample. Among the seven, 3I/Atlas stands apart because of its origin. As an interstellar object, it carries with it material not native to our solar system but forged elsewhere in the galaxy. Its chemistry may differ in subtle ways, reflecting the environment of another star's nursery. When compared with the other 6 comets, likely drawn from the Oort cloud or Kuiper belt, astronomers will be able to measure how local and interstellar bodies differ and how much the building blocks of cosmic matter are shared across the galaxy. This rare comparison will mark a milestone, the first time multiple cometary visitors of different origins are studied simultaneously under such favorable conditions. While scientists focus on data, the broader human community will be swept into the visual spectacle. Comets, once they brighten, are visible even to the unaided eye, their tails stretching across the night sky. The thought of 7 in motion at once suggests a sequence of sky shows that may span months, each comet rising in prominence before fading, perhaps overlapping in time to create moments when 2 or more tails can be seen together. For people in both hemispheres, for those in cities and those in remote regions, the sight will serve as a unifying moment, a reminder that the heavens above belong to all of humanity. Children will trace the glowing arcs, elders will recall other comets from their lifetimes, and stories will weave themselves into the cultural fabric of the era. The urgency of the red alert stems not only from the wonder, but also from the risk. When comets enter the inner solar system, fragmentation is always possible. Sublimation and thermal stress can cause them to crack, releasing debris that follows the parent body's orbit. Most of this debris burns harmlessly in planetary atmospheres, creating meteor showers that dazzle rather than destroy. Yet larger fragments can pose dangers. Even a piece only 100 meters wide carries the kinetic energy to devastate a region if it were to strike Earth. NASA's alert system, supported by observatories around the world, exists to detect these possibilities early. With 7 comets to monitor, vigilance becomes more critical than ever, for each one introduces variables, and each one could surprise with unexpected behavior. The interplay between natural wonder and practical caution mirrors the duality of humanity's relationship with the cosmos. For most of history, comets were seen as omens, unpredictable and often feared. In the modern age, science has reframed them as objects of study, their mysteries solvable through observation and mathematics. Yet the primal awe remains, and the warning tone of NASA's announcement resonates with that ancient unease. We may understand more than ever, but we remain subject to the movements of celestial bodies that dwarf our control. In acknowledging both the beauty and the hazard, humanity stands at the intersection of knowledge and humility. The patterns of visibility will also bring variety. Some of the comets may pass near the sun, visible only in twilight or during carefully timed intervals. Others may swing wide enough to be seen high in the night sky, glowing against constellations familiar for millennia. Photographers will attempt long exposures to capture their tails, astronomers will chart their positions against the stars, and entire communities may organize gatherings to witness the sight. It is likely that at least one of these comets will become exceptionally bright, rivaling the most famous of past centuries, creating memories that linger in human culture as much as in scientific records. One of the most intriguing elements is the question of whether this cluster signals a broader trend. The Oort cloud, that distant shell of icy bodies, contains trillions of potential comets. Disturbances in its structure could release more than a single body at a time, sending waves inward. Galactic tides or the passage of a massive object through nearby space could create such disturbances, though evidence remains circumstantial. Still, the coincidence of 7 comets arriving close together encourages researchers to revisit their models, to ask whether there are rhythms in the delivery of comets to the inner solar system. If so, then humanity may be living during a period of enhanced activity, a window when the skies are more crowded than usual. The technology available today makes this moment especially potent. Ground-based telescopes with adaptive optics can now pierce atmospheric distortions, offering clarity unimaginable to astronomers of past generations. Spacecraft positioned at Lagrange points provide constant, uninterrupted observation. Artificial intelligence is being applied to scan images rapidly, identifying faint comets long before human eyes could spot them. The monitoring of these 7 will be one of the most coordinated observational campaigns in history, an effort that will stretch across continents and cultures. Every image captured, every data point logged, contributes to a shared scientific endeavor that transcends borders. The psychological effect of multiple comets should not be underestimated. When only one comet graces the sky, it feels like a special guest, a rare visitor. With 7, the sense is more overwhelming, a cascade of arrivals that transforms the heavens into a stage alive with motion. The sheer frequency of sightings will alter how people think of comets, perhaps shifting them from rare marvels into symbols of a more dynamic and interactive universe. This psychological shift could inspire new generations to pursue astronomy, space science, or simply to look upward more often, reconnecting with a night sky that modern life too often obscures. Educational institutions are preparing as well. Teachers will use this event as a springboard to explain orbital mechanics, the chemistry of ices, and the history of cometary science. Museums and planetariums will host exhibits, while public outreach campaigns will guide people on how to observe safely and meaningfully. The confluence of scientific opportunity and public engagement ensures that this season of comets will leave a mark not only on data archives, but also on cultural consciousness. It is a chance to bring the wonders of deep space into the lives of people who may never otherwise think of themselves as part of a cosmic story. Culturally, comets have always inspired art. Painters have depicted them, poets have described them, filmmakers have imagined their impacts or their beauty. With 7 present at once, the creative impulse is bound to surge. Songs may be written, photographs shared widely, digital art circulated across the globe. The symbolism of comets, change, passage, illumination, resonates deeply, and multiplied by 7, it becomes even more potent. In literature and myth, 7s often carry mystical weight. Here, that symbolism finds real expression in the alignment of celestial events. The comet's trajectories will also intersect with planetary science in practical ways. Some may pass near Mars, offering an opportunity to observe their interaction with a planet's thin atmosphere. Probes orbiting Mars could capture data unavailable from Earth. Others may approach Venus or Mercury, where their gases respond differently to solar intensity. Each close pass offers a case study, expanding knowledge of how comets interact with varied environments. These comparative studies are invaluable, revealing universal principles and local variations alike. The fact that multiple such encounters are happening nearly at once multiplies the potential. As the months unfold, attention will focus on the moments of closest approach. Predictions of brightness, tail length, and visibility will shift as new data comes in, building anticipation for key nights of observation. Astronomers will track changes in coma size, fragmentation events, and the emergence of dust trails that may later intersect Earth's orbit, creating meteor showers. Already, enthusiasts are speculating about future displays of meteors tied to this cluster, events that could light up skies for generations. The interplay of comets and meteor showers underscores the interconnectedness of celestial phenomena, the way one event can seed another across decades. The global nature of the event cannot be overstated. No single nation owns the sky. No single community holds the key to observation. Instead, the 7 comets belong to everyone. They will be seen by shepherds in deserts, sailors at sea, astronauts aboard orbiting stations, and children in bustling cities. The unity of experience, 7 comets diving inward, their tails stretched across the heavens, creates a shared narrative that transcends divisions. In a time when humanity often feels fragmented, the sky provides a unifying story written in light across the dome of night. Speculation will inevitably arise about the symbolism of the event. Some will interpret the arrival of 7 comets as a sign, an omen of change. Others will frame it as a demonstration of the cosmos's indifference, a reminder of forces larger than humanity. Still others will see it as an invitation, an opportunity to expand knowledge, to dream beyond the confines of Earth. These interpretations will coexist, woven into the tapestry of cultural response. The scientific reality is clear, but the human response is varied, reflecting the richness of imagination. In the scientific community, discussions will already be turning to missions. Could one of these comets be a target for a flyby? Could a probe intercept and analyze its surface? With 7 candidates, the possibilities expand, though budgets and timelines impose constraints. Still, the lure is strong. Every cometary mission in history, Giotto, Rosetta, Deep Impact, has yielded transformative insights. To send a spacecraft to one of this cluster would continue that tradition, adding a new chapter to humanity's direct exploration of icy wanderers. The months of observation ahead will yield surprises. Comets are notoriously unpredictable, prone to sudden outbursts or unexpected collapses. With 7, the odds of at least one dramatic event increase. Perhaps one will split into fragments. Perhaps another will flare suddenly brighter than predicted. Such events will capture headlines, sparking waves of excitement. Scientists will analyze them while the public marvels at the drama. The interplay of prediction and surprise keeps the story alive, ensuring that interest does not fade but deepens with every twist. Above all, the convergence of 7 comets arriving together is a reminder of the living nature of the solar system. Too often, space is imagined as static, a backdrop of stars, but in reality, it is alive with motion. Planets orbiting, asteroids tumbling, comets diving. The red alert from NASA is not just a warning, but an invitation to witness this dynamism, to recognize that we are part of a system in constant flux. The comets are not anomalies, but participants in the ongoing story of cosmic evolution. As the skies brighten with their tails, humanity stands at a threshold of wonder. The 7 comets remind us of the depths of time, the reach of space, and the shared experience of gazing upward. They are emissaries from the edges of the solar system and beyond, converging in a moment that belongs to science, to culture, and to memory. Their passage is brief, but their impact will endure, etched into both data and dreams. A season of comets that reveals as much about humanity as it does about the icy wanderers themselves. The unfolding presence of 7 inbound comets, crowned by the interstellar traveler 3 I/Atlas, opens an extraordinary chance to think about phenomena that go well beyond visual splendor or near-term science. The event provides a unique platform to examine how the movement of icy bodies intersects with the long arcs of planetary evolution, cosmic architecture, and even the future of human exploration. To carry this story forward is to consider the many layers of consequence that such a convergence brings, not as aftermath, but as dimensions of possibility within the very moment of their approach. One of the most intriguing aspects of this simultaneous arrival is its impact on planetary atmospheres and magnetospheres. When comets approach planets, whether by close flyby or through trailing debris, they can temporarily alter local environments. For example, the thin exosphere of Mercury or the dense clouds of Venus could respond to cometary gases in ways that highlight unique chemical pathways. Even Earth's upper atmosphere might experience subtle perturbations as dust and charged particles interact with our magnetic field. These temporary shifts do not carry the weight of catastrophe, but instead reveal how interconnected the solar system truly is. In effect, the passage of 7 comets at once is not just a show in the sky, it is a living experiment in planetary interaction. Beyond immediate observation, the event sparks a re-evaluation of long-term cycles of cometary influx. Astronomers have long suspected that the solar system experiences episodic bursts of comet activity, possibly linked to the motion of the Sun itself as it orbits the galaxy. The gravitational tides of the Milky Way, as well as interactions with molecular clouds or unseen dark matter clumps, might disturb the far-flung Oort cloud, sending waves of comets inward. If this cluster proves to be part of such a cycle, then the current red alert could represent more than a singular event. It could be the leading edge of a pattern that repeats over vast timescales. To consider this is to situate humanity not only in a planetary epoch, but also in a galactic rhythm, a larger choreography where comets mark the beats. This moment also compels renewed attention to the technological frontier of comet interception. Every comet is a potential source of raw materials, water ice, carbon compounds, and metals that could sustain human activity beyond Earth. 7 comets arriving in quick succession presents a hypothetical menu of resource sites, each with distinct orbits and compositions. While humanity is far from exploiting such opportunities, the very possibility adds another layer of fascination. If one imagines a future in which spacecraft mine comets for propellant, or harvest them as way stations for interplanetary journeys, then today's alerts become tomorrow's maps of opportunity. The present arrivals could, in retrospect, be seen as practice runs for an era when comets are not only objects of study, but foundations of exploration. The convergence also sharpens the distinction between interstellar and solar system comets. For centuries, astronomers assumed all comets were local wanderers born of the same primordial disk that gave rise to planets. The discoveries of 1 Oumuamua and 2I/Borisov changed that, proving that other stars send their debris into our neighborhood. 3I/Atlas confirms this new category of visitor, and its presence in the current cluster underscores the diversity of cometary origins. By analyzing how its gases compare with those of its solar-born companions, scientists can test whether the chemistry of star systems across the galaxy shares a common template. If the molecular signatures prove similar, then life's potential ingredients may be universal. If they diverge significantly, then the uniqueness of Earth's recipe gains new meaning. Either way, the answers resonate far beyond astronomy, touching on the oldest questions of existence. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's red alert about 7 incoming comets? We want to hear from you. Thank you for watching and see you next time.